Hi guys, hope everyone is doing well and staying safe. I warmly welcome you all to the fourth and the final episode of the AWS webinar series done by the TN Tech Innovative in collaboration with the AWS focus group of 99X. So if you're into AWS serverless computing and want to be a hero from zero, this webinar series is going to help you out in a massive way. If you missed out on the previous sessions, you can go to our YouTube channel and check it out there as well. So this webinar series contains of 4 sessions, and the topics that we have covered so far are introduction to serverless computing, and AWS compute services, data store services. And today the topic will be on application integration services. In today's session, you will get to know what exactly are application integration services and how we can utilize it. So thank you for joining with us for this session. And if you have any questions, you can drop it on the chat and they will be answered at the end during the Q&A. So as the speaker for today, we have Manoj Fernando, who is an technical architect at 99X with over 9 years of experience. And he's also an active AWS community hero who has earned the respect and trust of the global AWS community. And he's also an active AWS community and Manoj also teaches people how to harness the power of cloud computing through his YouTube channel. He's also a leader of the AWS Colombo user group and also a Udemy instructor. Additionally, he also consults on serverless architectures and strategies for cloud solutions. So without wasting too much of time, I warmly welcome Manoj to take over the screen and go ahead with the session. Over to you, Manoj.
Thanks, Shoaib. Hey guys. Yeah, let me start sharing my screen. Let me know if you all see my screen.
Yeah, we can see it.
All right, great. Okay. So thanks, Shoaib, again for that introduction. So like you mentioned, I'm Manoj Fernando. So today in this session, let's talk about application integration services. So a little bit about me. I think we already Shoaib gave a brief. I'm a technical architect at 99X. I'm also working as serverless consultant. During my leisure time, I usually teach online. I have a YouTube channel as well as I have a couple of courses on Udemy. I'm AWS community hero since 2019, and I'm also the organizer at co-organizer at AWS User Group Colombo. So in this session, we are going to discuss about application integration services. But before we do that, since I just want to make this session sort of a self-contained session, I'd like to discuss a little bit information and things about serverless application development in general. Because I think most of you who joined today have been part of developing serverless applications or planning to develop serverless applications, particularly in AWS Cloud. So in this session, we'll first talk about the mindset that you should develop when you are developing serverless application, particularly in AWS. And then we'll discuss about these application integration services briefly. And we'll take a look at some use cases and see how these application integration services are being used in production applications and what are the considerations that you may have to consider and different challenges. So we'll deep dive a little bit after that. So if time permits, let's discuss in depth, and you guys can also ask me questions. So yeah, so let's proceed. So let's start with serverless mindset. I think when we are developing serverless applications, the traditional mindset of application development needs to be a little bit changed. So during the 8 years of experience that I have building production applications on serverless, and also working with large-scale migration projects to AWS, particularly to serverless, I've seen that the mindset that we usually have in building traditional applications, which may be hosted in a virtual machine or on premises, needs to be a little bit changed. So that's why I will start with this section first. So first and foremost, one thing that does not change is that we need to think always about the business requirement whatsoever. So it could be you are developing an on-prem application or application hosted on a virtual machine, whatsoever. If you are developing an application, you are developing for a customer, and there'll be different users who will be using your application, and that application should address some business requirements. So your application must cater for both functional and non-functional requirements of that particular business use case. Excuse me. So particularly in serverless, I'll introduce you different type of serverless services where you can plug into your serverless architectures. But even there are new services are being added to the list of services where you can use in AWS. It really doesn't matter whether you are using the cutting edge service or you are using some old service. It really doesn't matter if it doesn't serve your business requirements. So it's very important, even if you're using any cutting edge services, make sure you cater for your functional and non-functional requirements. Next is the serverless first thinking. So this is something little bit different from traditional application development. When we are thinking about serverless first, you always think about, are we able to provide a solution using a serverless component or serverless architecture? Let's say that you are developing a new application, or you are adding a new component to an existing application. So always you should think about, are we able to provide a solution serverless first? Meaning that, are we able to use some of the serverless services offered by AWS or any other cloud providers if you are using other cloud platforms? Are we able to provide this solution with that? Why? Why should we do that for serverless first thinking? One aspect is to reduce the cost. Regardless the company that you're working is a startup or established company, cost is a concern. In general, everyone is sensitive to cost. So if you're thinking about serverless first, and if we start developing application with serverless services, you essentially do not pay for any idle time. Most of these serverless services, you only have to pay for the usage. So in that case, you're going to reduce quite a bit of cost, particularly if you are developing a startup and your product may, at the beginning, do not have a lot of users. And if you are using, let's say, EC2 instance or something like that, then you're going to have to pay for that EC2 instance uptime, regardless your users using it or not. But with serverless services, you essentially do not have to pay for the idle time because you are only charged for the usage. If there are a lot of users, then you will have to bear some cost. But still, again, in the same time, you will incur some revenue as well, generate some revenue as well. So it's good idea when you're developing an application from scratch or you're adding a new module, always think serverless. Are we able to use some of these serverless services, particularly for reducing cost, as well as for scalability aspects? I'll talk about scalability in depth in a couple of slides ahead. Let's imagine now you're not able to find a completely serverless serverless solution for your, let's say, a new application or a new module that you are going to develop. So in that case, you can still think about, are we able to use a hybrid architecture? Meaning that you can use some serverless functions which handle some of the cases in your module, and also where serverless might not fit. Because if you think about serverless functions and so on, they are not usually used for long running processes. So if you want to have some long running processes in that particular new module, probably you will also include some containerized applications. So in that case, you can use these hybrid architectures you will both use containers as well as serverless services. Together with that, you will be able to cater for your business requirements. Next, it's about using managed services. Now, in AWS and other cloud providers, they typically provide these managed services. So managed services essentially meaning that they will be patched, they will be managed, all the provisioning of these services, maintaining the security aspects of these services will be managed by the cloud provider. So when you are making decisions to develop a new module or a new application, or you can always think about, am I able to use an already available managed service? For example, let's imagine that you are developing an API. This is a REST API. And you can, of course, create your own REST API using, let's say, if you're into Node.js or anything like that, maybe you can use Express to create your own API and host it in a container or an EC2 machine or something like that. Or maybe you can also think about, I can also use API Gateway. So API Gateway is a managed service from AWS. So, and that will take care of so many administration overhead for you. If you are maintaining your APIs, you have to make sure you will scale your API properly. You have to worry about the scalability aspects of it and the security aspects of it. There are a lot of consideration when you are managing your own APIs. But if you're using services like API Gateway, which is fully managed service from AWS, most of these things are handled for you. The security aspects, the throttling, and the scalability aspects of the service itself. So those things are managed for you. So you only have to worry about how do you create your resources together with this particular API Gateway managed service. So don't try to reinvent the wheel. Always use these managed services. And because when AWS engineers, when they're developing these managed services, they're thinking a lot about security, availability, so on and so forth. But when we are developing our applications and when we are creating our services by ourselves, we probably not pay 100% attention to these aspects. So when you're using managed services, in a way, your team is also comprised of AWS engineers. And they typically, most of these larger teams, they adhere to these best practices. So when you're using these managed services, you have a few things to worry about, really. You can focus on your application development rather than managing these services. Next, you should also think about decoupled architectures. So maybe not every application that you should develop, that you are developing, need sort of a decoupled architectures, but it's always good to think about, are we able to include some event-driven architectures in my application? So what are the reasons for this? Because if you are working with a team, and let's say if it is a large team, and when you create your application in a decoupled component, you can get your team members to manage these components separately. So they don't have to step on each other, and then they can manage these services separately, and then they can consider about the scaling of these services separately. So if you are, let's say, for example, let's take a example on user management. So imagine now you are developing an application, and you will develop your user management also in the application itself. So in that case, if you start getting so many users into your application, you have to scale your application services, because your users are coupled with your application itself. But instead, if you decouple your users in a user store, then you don't have to scale your application infrastructure when your users grows. So you can handle the scalability of these two components separately. So that's another advantage. So it's easy to scale. And next, you should think about the application complexity versus the code complexity. Now, this is an important thing. Now, let me explain why. Now, if you think about this diagram, by the looks of it, you can see it is connected with so many components. So there are lots of ways these components communicate with each other. By the looks of it, it looks very complex. But in the same time, you can write the same application in a single application code and put that into a EC2 machine and serve it to your users. Or you can put that into a container and serve that into users. And in the other hand, you can create sort of a decoupled architecture like this. So which looks very complex. But still again, if you little bit zoom into this architecture, you can see that code complexity in this architecture is offloaded to the architecture. So in that, if you are like developing a monolithic application where you will have to consider all these complexities in the code, in this case, you will offload that complexities into the architecture. So the beauty of this is, when it comes to these computations, like the Lambda function that you see in this diagram, are very simple. Now, these are mostly single responsible Lambda functions. They will do one thing, and then they will do that one thing really well. But the other complexity is about the logics, how to route traffic between these components, and those things are offloaded to the architecture. So before you jump to conclusion, whether this is a very complex architecture or not, you should think about how the code complexity could be if you are to put all these logics into one monolithic application. Next, it's about adding observability. Now, when you are developing an application like this, it's important that we have a very good observability strategy, because there are lots of connected components, and these are loosely coupled. So if there's any errors, any issue that pops up in this architecture, it is very hard to identify and troubleshoot. So that's why you need to have a very good observability strategy where you will be easily find out the errors in your application architecture and be able to troubleshoot it. For example, there are tools like Lumigo, Tundra, AWS X-Ray, where you can easily connect with your application architectures and easily find out errors, issues. And these tools, they will provide you where the issues occurs and at what point there are bottlenecks are found, and all this information is available to you right away. Next, also always designed for the extensibility. Why it is important, particularly if you are developing a cloud native application using lots of cloud native services, these services gets lots of new updates every year. And if you think about larger events like AWS reInvent and other conferences in other cloud providers, they are introducing lots of innovation every year. So if you do not keep provisions to update your architecture for these new updates or the new features that they release, you will soon be deprecating your services. So you won't be able to get those goodness that is come out of these new services. It could be the cost wise, it could be the performance wise improvements, though those things could not be added to your architecture if you do not allow these extensible architecture. I'll show you how to design your architectures in an extensible way where you can easily plug in new features and introduce new architectures. And then security at all layers. So security is something very important. When we are developing applications, particularly serverless application, we have to think about security at multiple levels, starting with the edge level. So edge level is the outer level of your application, where you will have a CDN like CloudFront, which will become the first point of contact of your user requests, and then they will be forwarded to your API level, and then the API, let's say you are using API gateway and something like that, and the API gateway then connect with your Lambda function associated with that, which is essentially the application layer. And the Lambda function then communicate with the database like Dynamodb, so it's at the database level. So at all these level, you should focus about security, because security is important, and it is very vulnerable nowadays, this modern application, to the security threats and hackers. So it's important that we attach security or add security at all these levels. So in this case, you can think about managed services like AWS WAF or Web Application Firewall, which you can easily integrate with most of these layers. And then the caching. So caching should also be considered where necessary. So in the same way, you can also add caching at the edge layer, API layer, application level layer, and database layer. And further you go outside or outward, close to the users, the amount of cost that you have to bear for caching minimizes. For example, if you add caching at the cloud front level, the cost for caching is quite cheap. And if you go to API gateway level, you can add caching. Then again, the cost is, you have to bear some cost. But if you go further into the inner layers of your application architecture, the cost aspects goes increase. So you can decide a good caching strategy for your applications. And then the use of purpose-built databases. I think you already had a discussion in the previous session about databases. So since we are using cloud platforms, it's very easy to mix and match databases as appropriate to your application architecture. This is a luxury that you should really make use of. For example, you can have your DynamoDB for reads and writes, and if you want to do search optimization, free text search and sort of search optimized queries, then you can think about services like Elasticsearch or Algolia, which is really good alternative to Elasticsearch. And if you want to do some computation on time streams, you can think about using Amazon Time Stream. And also, you should also think about synchronizing these databases in an asynchronous manner as well. So you don't have to you don't have to write something to DynamoDB and again write the same thing into the Elasticsearch and again index add that information into the Amazon Time Stream database. You can do this in an event-driven manner, which is quite scalable, although you have to bear with the eventual consistency, which is like the data will not immediately available in all the stores, but eventually they will get there. And you can think about the use cases if that makes sense to your application architecture. All right, so these are the things that you should think about when developing serverless application in general. But now let's get to the point about integration services. Now in AWS, there are multiple integration services offered to you. But in the first place, why should we use an integration service? So what does it mean to mean by an integration service? Now, when you are developing an application, we usually have to communicate from one service to another service. Now, this service could be a service in the AWS itself, or it could be something outside, some sort of a third-party service where you need to communicate as part of your business requirements. So when you are doing this integration between services, these integration services really comes in handy to handle different challenges which otherwise you will come across. Now have a look at this. So this is sort of a traditional serverless architecture. Why I mentioned traditional is like this is very common architecture where you will have your users who will be consuming your application. Let's say you have a REST API and the REST API is hosted in an API gateway service. And then you have a Lambda function and this Lambda function then communicate with the databases like a DynamoDB. So this is something very common, and it's a very good architecture, in fact, because if you think about the scalability aspects of this, it's really good because most of all these three services that you see to your right side are managed services: API gateway, Lambda, DynamoDB. Now, these services scales well as well. For example, API gateway, you can receive so many requests per second. The throughput can be really high. And Lambda also, you can get a considerable amount of throughput, but like limited by the region limits. I'll get to that in a bit, how to mitigate those. And then the DynamoDB. DynamoDB as a database, usually if you're thinking about other type of databases, usually these databases are not scalable as serverless function. If you get, let's say, 100 requests in parallel, there will be 100 Lambda function invoked by the API gateway, and those 100 Lambda function will send 100 requests to DynamoDB. So DynamoDB is able to ingest these requests because it's a managed service. But if you think about the database services like, let's say, MySQL or something like that, maybe not as scalable as Lambda function, serverless Lambda function. So in that case, since in terms of the managed services, this is a very good, we can reach a good scalability, up to a good level of scalability with this architecture. But if you think about other characteristics, now this is particularly a synchronous communication. Users will request something through API gateway, and the Lambda function will query that thing information from the DynamoDB. It will return to that. Request response cycle will always occur. So in that case, what about some long running or some lag happen? Even it could occur in the logic. It could be something. There's a heavy business logic that is performed at the Lambda level, or it could be the Lambda may be like connecting with a third-party service, which may be offline for some time. So in such a cases where the latencies could occur, what about the user experience? Because if you really think about that, this is synchronous application, synchronous communication. Users will wait until the response is returned to them. But if anything latency issue occur at any point of this particular diagram, the users will have to wait. So in terms of user experience, that's not good. And in the same time, like I mentioned, if you think about connecting to a third-party service instead of DynamoDB, and these third-party services are not managed by us, and they may be not as scalable as DynamoDB. So when there are lots of parallel requests, the Lambda starts flooding requests to these third-party service, they could also fail. So then there's a problem and the request will accumulate. So the users will not be very happy about it. So these are some of the consideration when we develop applications with the synchronous communication patterns. So that's why when we are connecting with one service to another, we usually prefer some asynchronous event-driven architectures. Reason is that we can handle these user experience issues quite easily because in the asynchronous communications, users are not waiting until the final result is returned. Whenever something users want to process something, they will give that order, and then they will get some response, the acknowledgement. Okay, your response, your request is being processed. You will be noted once it is performed, once it is complete. So in that case, users know, okay, their application, their request is being catered. And once it is complete, they will be notified. Either they can maybe click a button and get the status of that, or else we can write some real-time communications. We can implement some real-time communication patterns where once the processing is complete, in real time through WebSocket connection, we'll inform the users. So in either case, users will be notified. If there's any issues, that will also be notified. So users know, okay, something has got not properly, didn't work properly. So they may have to retry it and all that. So that's where integration services really comes in handy. So there are a few categories. So starting with API management. So in the API management category, you can find these two services. We already discussed about API Gateway. API Gateway is a managed REST API service provided by AWS. And then if you have a GraphQL API, Then again, there's another managed service called AWS Apsync. So AWS Apsync is a managed GraphQL service offering from AWS where you can run your GraphQL API at scale. Next, we have event bus category. So essentially, this is you can create your event bus, ingest event into the event bus, and then send these messages or the events to the targets as appropriately. One of the services, the popular service in AWS to handle your event buses in a managed way is this AWS Eventbridge service. We'll discuss a little bit more about Eventbridge in upcoming slides. And then we have the messaging category. So in the messaging category, this could be point-to-point communication, pub-sub communication, and so on and so forth. So we have a bunch of services like SNS. So SNS is a simple notification service where you can create your topics and you can publish messages to the topics, and then subscribers can subscribe to these topics and then they will receive these messages. And you can do it in a highly scalable manner with this SNS service at a very low cost. It's a very cheap service. And then we have SQSQ. This is the simple queue service. This cloud AWS proprietary queue service. So you can put any messages to this queue, and then you can define your workers. You can define Lambda function as serverless workers to consume these messages in the queue, and you can process these messages batch-wise to minimize the load to your downstream services. So you can use SQSQ and SNS. Both SNS and SQSQ are proprietary services. But when it comes to, let's imagine you want to migrate your existing application over to AWS, and you're already using queues like RabbitMQ or ActiveMQ, these open source type of queues. And if you want to migrate your services into AWS, then you can use Amazon MQ. So it's a managed service where you can get your existing RabbitMQ, ActiveMQ type of open source queues into AWS. That's another service where you can use, particularly useful when you are doing migrations. And then the last category is the workflows. So when you are building application, we essentially come up with handling different type of workflows. Let's say order processing workflow. So in such a cases, we have some options. We have AWS Step Function, which is the state management service, the cloud, the proprietary service from AWS. And also you have Apache Airflow, sort of an open source type of workflow management service. Again, it's a managed service offered by AWS. It is offered as a managed service from AWS. You can make use of that as well. So these are the top categories in the integration services in AWS. So let's dive into these services a little bit in more detail. So I'll start with API management, API gateway versus AWS Apsync. Now, if you think about these two services, like I mentioned, Apsync is a fully managed GraphQL service. So if you have your GraphQL schemas and you want to create a GraphQL API out of this schema, you can easily use this AWS Apsync. And both of these API gateway, as I already mentioned, it is essentially used to host your REST APIs. You can create your REST APIs with AWS API gateway, Amazon API gateway. And both of these services, they support caching, monitoring, logging, which otherwise you would have to implement by yourself. So these things are provided to you inbuilt, and you can easily use these for your purposes. And then the best part of using these managed services is the direct integration with other AWS services. Now, both AWS Apsync and API Gateway, they have direct integration to most of these AWS services. API Gateway is particularly like it supports with so many AWS services. But there's one thing you should remember is that when connecting API Gateway with other services as a service-to-service proxies, you have to you have to do this integration with templating languages like VTL or velocity templates. So maybe there's a little bit of a learning curve there, but still again, once you're familiar with VTL, you can easily connect your API gateway with other services directly. Or else you can also use a Lambda function to communicate with these other services. So the API gateway first invoke a Lambda function, and in the Lambda function, you will use AWS SDKs to communicate with the other services. However, if your Lambda function doesn't do much logic, business logic, other than like transporting the data from API gateway to the other AWS services, typically what is recommended is to go ahead with the direct integration with VTL template. But however, if you are doing some transformation in the Lambda function, by all means, use a Lambda function when connecting with the other services. And same goes with Appsync as well. You can easily create your resolvers in Lambda, Dynamodb, RDS, Elasticsearch, with these data sources. You can easily create your resolvers towards these data sources. And both of these services, they have a direct integration with WAF or Web Application Firewall, which is very good. And I recommend you using it if you are not already using that. You can get a very good security improvements by just integrating WAF. You can create your own Web Application Firewall rules to mitigate top 10 OWASP vulnerabilities, and so on and so forth, bot attacks. There are lots of rules you can add. You can write your custom rules, and both of these services directly integrate with WAF. And then AWS Apsync, they support group-based authentication, whereas in API Gateway, they do not support group-based authentication, meaning that if you are storing your users in a user stores like Cognito, you can create your users and segregate them into user pool groups, and then you can attach permission to these user pool groups. And if you're using Appsync, you can use this permission directly with Cognito, thanks to this group-based authentication. But if you're using API Gateway, you have to probably use a Lambda authorizer or Lambda function to get these permissions properly added to your Lambda functions. And then both of these services support WebSocket, but Appsync WebSockets is highly scalable and it's high level. You don't have to do much in terms of implementation, but when it's come to API Gateway, it's low level. You have to write Lambda functions to handle connections and all that. And there are some challenges to that. For example, when you're broadcasting to lots of users in real time, it's very difficult with API Gateway, whereas in Appsync, you can broadcast to millions of users very easily. So that's the comparison of those two services. Next, let's move on to our event bus category. So there's the most popular service that you will find is EventBridge. EventBridge is typically used to implement this choreography pattern, event choreography pattern. Now, EventBridge is a managed, you can create a managed event bus. So event bus is essentially you can ingest events. So events are, let's imagine in your application, you are building an e-commerce application and users starts creating orders and you will receive these orders. You can add these orders as a JSON payload into EventBridge, right? So events are essentially these JSON payloads. It could be different as well, but mostly commonly these are JSON payloads. You will add it as events, and once you add them into EventBridge, then you can create different targets where you can publish these events as appropriately. Let me show you this particular diagram. Here, as you can see on your left side, you can see we can generate events from different ways. In the middle, you will see your custom application where you will use AWS SDKs for EventBridge to generate events and create events and put them into event bus that you create. Or else you can also connect your event bus with other SaaS services, SaaS app providers. For example, let's imagine you are using MongoDB Atlas. In MongoDB Atlas, whenever some whenever some item is added to a collection, you can connect you can make a connection between the MongoDB Atlas and EventBridge in asynchronous manner, where MongoDB will publish those events internally to your event bus. So once you have the messages in event bus AWS, then you can integrate that with other AWS services. This is a very neat example, because if you are using, for some reason, MongoDB like databases as opposed to Dynamodb, which is a cloud native databases in AWS, you still want to implement some event-driven architectures with these databases. Something stored in the database, you want to take some actions against it. So for such a cases, this type of integration really comes in handy. Whereas in DynamoDB, you have a direct integration where you can use DynamoDB streams to trigger Lambda functions and take actions once items added to DynamoDB. But in this case, for MongoDB also, you can do similar patterns with EventBridge integration. And there are other AWS services which can also publish events to EventBridge. However, once you have these events in the event bus, then you can define your targets. So targets could be AWS services, or it could be different API destinations, because EventBridge supports so many different type of targets. And how you will forward these messages to these targets is through rules. You can create event rules, and in the event rule, you can define what type of event should be forwarded to these targets. You can easily do that with event rule. And then whenever messages are appearing in the event bus, if that messages matches with the event rule that you have defined, they will be forwarded to the target immediately. Yeah. So EventBridge is essentially used as a serverless event router. So you can route your events to your targets in an intelligent manner. What I meant by intelligent is you can also look at the content of these messages and use that attributes in your message payloads to do the routing. So there's this content-based filtering feature, which is really useful if you want to intelligently route your messages to your targets. And also, EventBridge supports event archives and playbacks. So you can create an archive. That means once you create an archive, you can look at all the events at that point in time, and even you can play back those events just in case. And there are so many other services that it supports, like schema discovery, so on and so forth, but I'm not going to go into that detail. So in terms of EventBridge, let me take you through some of the pros and cons. So in terms of pros, EventBridge, these targets are completely decoupled. Now, as part of this choreography pattern, once you have an event rule, you can create many event rules. You see now, for one particular event bus, you can create up to 300 rules. So in these rules, let's imagine now you are developing an e-commerce application and an order has been created. Now, then you can create a rule. If this order has been created, should I do something important? For example, you have to do the loyalty calculation, or you may have to call the shipping services and all that. So, or it could be something new as well. That something you guys haven't yet thought about, but some requirements comes in the future as well. But you need to do it as soon as order is created. So in that case, you simply have to create a new rule and associate that rule with the attribute that you want to filter, and then get that messages or get that events to that target, and then do the processing. You see now the targets doesn't really have to have any direct tightly coupled to the event bus. As long as you can create a new rule, those messages, whatever the messages that matches the rule, will be receiving to that, will be forwarded to that particular targets. So this is very useful for innovation as well. Now imagine once one of these targets complete its processing, again it can push another message to the same event bus or a different event bus, right? And then you can write another service listening for that particular type of event and receive those type of events. And then you can take the processing further on. So likewise, these targets will be completely decoupled targets. But in the same time, once you have these completely decoupled targets, it's that's a pro, by the way, because you can evolve your architectures very easily, and you can introduce new components, new services, and depending upon the requirement that you will come across in the future, you can easily do that. But in the same time, it's difficult to understand the flow, because you can publish events to event bus in many places. You can again publish events to the same event bus, and then those interested events will be forwarded to those targets and so on. So it's difficult to understand the flow of a certain process. So that's a con. You can see the third con that I have mentioned in the table. It's difficult to understand the flow of the process. So it's again, the double-edged sword sort of a thing. So it's, yeah. And then, hello. Yeah. So then the other thing, another important advantage is that these targets can be scaled independently. Now, these targets are completely independent, and you can scale your targets as you need. So that's another advantage. And there are any single points of failures, because Eventbridge is a managed service, and you can create your targets to it. And these targets, if these targets have rules that matches with the events, then they will receive these messages. And in fact, you can define DL queues or dead letter queues at the target level. So if these targets could not be reached, Eventbridge will put these messages into these DL queues as well, dead letter queues as well. And yeah, the last pro is other system can build on these events. Now, if, like I mentioned already, if you have another new requirement, you just have to create a new event rule and listen for these messages and then do the processing. And on the con side, end-to-end monitoring is difficult because you don't really have a direct flow of process. The events event could appear in different ways, and since the targets will be only considering the events that they are interested in, we can't actually dictate a particular process. Okay, you should do this first and that first, and so on and so forth. So and there are other difficulties such as implementing timeouts, because whenever there's a message available in the event bridge, it will directly send it to the targets. If there's no any matching target, the message will actually disappear. So it's difficult to implement timeouts, because usually when we are developing workflows and all that, sometimes we have to wait for some time, have to have some timeouts and all that. It's difficult. Yeah, and also if something goes wrong, how are we going to roll back it? Because this is like a very distributed in nature. So if something happen in the flow of processing an order, then how are we going to roll back it? So these are some considerations or cons, I would say. So in order to prevent that, there's another service. There's this orchestration service called step function. So this is typically focused on workflow management. And here's a workflow. Now you can see a graphical view of this as well. This is basically creating an order, and you'll start and you first check the inventory. And once the information is available, once the once there's enough inventory available, then you will calculate the total, and then you will check if the user needs any redeeming their points, and if they need redeeming, then they will redeem the points, and then they will bill the customer. You can see the green color ones is sort of the happy path, I would say. Right? But on the other side, when at the beginning, when they're checking the inventory, if there's not enough inventory items available, then we can route that request to a different step, which is the book out of stock error. So there we can send an error to whoever the client calling this event workflow service. Okay, there's no any stocks available. And likewise, if there are no, if this is, let's say this is sort of a you can book books online, and if that particular book is not found, then you can again throw errors and so on and so forth. But this is like, the first two errors are straightforward. But what if you think about the billing the customer step, there where there's an error occurred in charging the customer. So at that time, you have to redo all the previous steps. With even with the AWS step function, you can easily handle these retries, and you can easily handle these rollbacks using patterns like Saga patterns. Now you can see if something goes wrong with the charge or at the step of preparing the order, you can refund the customer. And again, you can restore the quantity because you already reduced the number of items from the inventory, right? So you will restore that number that you reduce. Again, you will restore their redeem points. So you can like roll back all that. And you can do that in a very controlled manner. And that's particularly the reason to use AWS step functions. Unlike in Eventbridge, where the choreography pattern, you are unable, it's not unable, it's difficult to handle these sort of rollbacks, but with step functions, it's very easy. So in the same time, let's discuss some of the pros and cons of step function. So as for the pros, it supports up to 200 plus AWS SDK integration out of the box. So you can, from step function, you can call onto Lambda functions, SQS queues, and there are so many services you can directly call from AWS step function. That's a very good pro. And then you can define your workflows visually as well, because unlike in, let's say, the choreography pattern, where it's difficult for somebody to understand how the flow of this traffic happens. But when you look at a diagram like I showed you previously, it's very easy to understand how the flow goes. And then you have different type of states available to you. For example, wait state is a very important state. You can wait, or you can have a timeout up to 1 year. So for example, let's say in this particular state machine, you will at any point in the state, let's say, calculate the total. You can wait that process up to 1 year. So that's like really amazing. And maybe this is not applicable for this particular context, but wherever it is required, you can do that. For example, let's imagine you are building a pizza delivery application. So in that case, once the pizza has been dispatched, the delivery guy will take it to the home of the customer. And once he got there, then he will click a link, and then he will resume this workflow. Yeah. So it will pick up from where it sort of hold the workflow and continue that. So it's very powerful. So with all these pros, what are the cons there? So one of the major cons is it's costly, particularly if you are using standard workflows. Standard workflows are charged by the step transition. So every time you transition from one step to another step, you will be charged, and you will be charged $25 per million transition. And although it looks like million transitions is a large number, but when you are really using it, you will find out it easily get exhausted. But the other alternative is to use express workflows, but there are some limitation to express workflows and so on. Yeah. So moving on, how do you think about using Eventbridge as a choreography pattern, and at what point do you use step function as orchestrator? So that is the place where we should think about the bounded context. Now, usually when you are developing application, we are developing microservices, right? So when you are developing microservices, each microservice is sort of bounded to a context. So I think you must have heard about this domain-driven design. So here, if you are communicating among these bounded contexts, in this example, invoicing is one of the contexts. And if you, once the invoicing is complete, if you want to contact these shipping aspects of this application or shipping a particular order, that's a separate bounded context. So in that case, once the invoicing is complete, you can put a message into the event bridge. And then for that event bridge, you can create a target rule. So that message will be received by the shipping service, and then it will continue the shipping. But if you think about within the bounded context, like invoicing aspects of it, if you want to connect with multiple services and there's a certain workflow to it, then it's advised or the recommended to use step function to handle these workflows, because if there's any errors, you need to retry it, and troubleshooting, maybe you have to wait for something. So all these things are very easy to use with step function. So the rule of thumb is, if you're within a bounded context, go ahead with the step function. And when you're communicating among the bounded context, use an event bridge. Okay, so we are almost an hour spent. So let's see, how much time is available for us, Shuaib?
We can use some more time. It's okay, I think.
All right. Yes. Yeah. Okay, but before discussing the use case, because that could take some time, I'll also try to give some notes about SNS and the other integration service. Now, when it comes to under messaging category, we have another service called SNS. So this is simple notification service. This is pretty much used to communicate to the clients in particular. For example, let's imagine you want to send a push notification to your customers. So in that case, you can easily use SNS. And on the other hand, if you want to communicate internally as a pub sub service, publisher subscribe service, you can also use SNS. SNS and EventBridge are pretty much similar, and actually EventBridge is the successor to SNS, but still you can use SNS if you are dealing with very high scale. Now, as maybe you might have remembered, for one particular event rule, you can have up to maximum of 5 targets. But with SNS, if you create SNS topic, you can have up to 12 million subscription for one particular topic. That's a huge number of subscription where you can subscribe to where you can set subscription to your single topic. And then it's highly scalable as well. If you create a topic in SNS, you can publish up to 30,000 messages per second. And I think this is a soft limit as well. You can increase these as well. And particularly used for end user communication. And it's cheap. So compared to EventBridge, SNS is cheap. But the con side is it does not support intelligent routing. Now, one of the the benefit of using EventBridge as a pub sub service is that you can filter messages by the message body, header, whatever the content in the particular JSON object. But in SNS, you can only access these message attributes. You can't go beyond that really. So again, when you're using this service, it's up to your discretion at which service really suits you well, and then use it accordingly. And then we have SQS which is the durable message queue. So in the durable message queue, unlike SNS EventBridge, where they do not store the message for some time, SQS is durable. You can store a message up to a certain number of days. And then this is more like point-to-point communication. You can put message into a queue, and there will be one consumer for that particular message. It's not like pub-sub sort of a communication where you can publish a message to a topic like SNS or Eventbridge, where and then you can have multiple subscribers who will receive the same message. But in SQSQ, you have one you can have, it's basically point-to-point communication, right? So there are a few things, particularly when you're using SQSQ with a Lambda consumer. Now, this is a very common pattern that we typically use in production application, because we don't want to create a EC2 machine or EC2 server or even a container to consume message. And of course, there are use cases to that. But typically, what we start with is, are we able to use a serverless consumer to these message queue? So that's where one of the common use case is to use SQS with Lambda consumer. Now, there are several considerations which I like to go through quite fast. Because of this is a serverless worker, you don't have to pay for any upfront time, right? So whenever there's a message available in the SQS the Lambda will start consuming those messages. Otherwise, you don't have to pay for these Lambda functions. That's one of the good thing to use Lambda function as a consumer. And there is this default concurrency limit in Lambda functions, meaning that when imagine now there are 100 messages pops up in the queue at once, and if you connect your Lambda function to consume those messages, there will be 100 Lambda function invocation. That is, of course, if you don't use batch processing with Lambda. But if you do not want to have 100 Lambda function, for example, like one Lambda function per message, you can batch these messages as well. And why do you need to batch these messages? Because there is this default limit, regional limits in AWS. You can have up to 1000 Lambda function concurrently. And this changes region to region. But still, again, the default limit is you can have up to maximum up to 1000 Lambda function concurrently. This is off limit though, but still, again, it's good that you will think about this limitation, because you can easily fix that if you do some batch processing with SQSQ. When you're creating SQSQ, you can set the batch size, for example, let's say 10. So what happens then is the Lambda function, if there are 100 messages pops up in the queue, the Lambda function will receive 10 by 10 batches, message batches. So, here, one Lambda function will receive 10 messages. But in the same time, if you do not have 100 messages, but you will get, let's say, 3 messages in the queue, still again, Lambda function will receive only those 3 messages. It's not going to wait until it receives 10 messages in the Lambda function. But however, one of the purposes of using batch processing is to reduce the number of Lambda invocations. We sometimes want to process batch by batch. And because of the very reason I just mentioned you just before, like let's say if you have only 3 messages, Lambda is not going to wait until 7 more messages receive. It's going to like execute it right away. But if you want to do some waiting, then you can set the maximum batch window size. So there you can say up to how many seconds should you wait before the Lambda function process. You can easily do that with maximum batch size attribute. And then what happens is when there are like more messages, Lambda at once in parallel invoke 5 Lambda function, 5 batches in parallel. For example, if your batch size is 10, there will be 5 Lambda functions, and these 5 Lambda function will receive 50 messages, 10 each. But still again, if you have 100 Lambda function, 50 will be left over in the SQSQ. Then Lambda, what it will do is, it will invoke more Lambda functions, up to 60 Lambda functions in 1 minute, which will receive 10 of these messages each. So that likewise, it will increase its concurrency, even though you are using batch processing. So it's important to note that even if you're using batch processing, the Lambda could have concurrent invocation. If, however, you want to limit that, because there are different reasons, you probably want to ensure at any point in time you need a one Lambda invocation. So in that case, you can use these other attributes like reserved concurrency. For one particular Lambda function, you can set the concurrency by force. Okay, this particular Lambda function X, you can have maximum up to 5, or you can even set it to 1. That means no matter how many number of messages available in the queue, even in the batch processing use case, you will only have one Lambda function invocation. So this way, it's you can control this Lambda function concurrency. This is particularly useful if this processing in the Lambda function involves calling into third-party services, which actually not developed for high scale. And the other important thing is when you are setting your batch messages, when you're processing messages batch by batch, let's say the same example I took previously, 10 messages in a batch. When Lambda processes that 10 messages, some of these messages could fail. Like let's say 3 out of 10 messages, 10 of those messages failed, but 7 succeeded. So in that case, there are some partial failures. So it's very important that you handle these partial failures. Otherwise, you will end up with weird issues, and you won't be able to like fix this straightforwardly as well. So it's very important that you pay attention to these nitty-gritties. So it's important that you handle your partial failures properly. And so one way to do that is you can return those failed messages back to SQSQ. So once we particularly explicitly return these messages stating that these got failed back to SQSQ, SQSQ will add those messages, add those messages back into the queue, and another Lambda function will start picking those failed messages. And the other important thing is the visibility timeout. Now, when we are adding a message to SQSQ, there is this timeout called visibility timeout. What does that mean is when a message is processed by a worker, in this case, a Lambda function, you can set a timeout. You can say if the timeout is, let's say, 5 seconds, if this Lambda function couldn't process that particular message within 5 seconds, SQS will re-add or make that message available in the SQSQ again. So probably at that point, Lambda is still processing that message, but still again, once that timeout is passed, that message will pop back in the SQSQ. So another Lambda function can work on it. So this could again prone to errors because your message may be still being processed, but still again, the same message appears in the queue. Another Lambda function will start processing that, it will be a very difficult thing to debug these type of issues. So that's why you need to properly set the visibility timeout. And the recommendation is to set the 6 times of the Lambda timeout. Usually when you are creating a Lambda function, you can set the Lambda timeout as well. The recommended approach is to set the visibility timeout 6 times of that Lambda timeout. Plus, if you are using the maximum batch window size, you have to add that number of seconds as well, because maximum batch window size is always the waiting time. So you need to add that waiting time also if you are using maximum batch window size. So the function to calculate the visibility timeout is 6 times the Lambda timeout plus max batch window size. And then let's imagine these messages somehow, because of some issues with the message, we call these poison messages, came back to SQSQ. Lambda couldn't process it whatsoever. And then they will again comes processed by another Lambda function. Still again, they couldn't process because something wrong with the data. So at that point, SQS will keep showing the messages in the queue, and the Lambda will keep processing that. Still again, it couldn't process it properly. At that point, you will exhaust your Lambda resources, and that's like very error prone. So in that case, what you can do here is you can set a redrive policy telling that if you receive a message this many times, let's say if you receive a message more than 3 times, do not process it again. Put that into a DL queue, dead letter queue. So in the DL queue, then you can later observe it what has wrong, what was the wrong with the messages. So always use a DL queue. Now, these are some practical tips that you should think about when using SQS queue with Lambda function, particularly in your production use cases. Yes, with that, I'd like to conclude this. Actually couldn't go over the use case, which I was planning to discuss with you all. But now that the time is late, maybe we can discuss this in a different session. Yeah, and also I have a particular video recorded on this topic as well. I will also share the link through the organizing team. So you can again check that and look at how these integration services can be used in a real world use cases too. Thank you very much. With that, I will conclude this session.
Thank you, Manoj. So yeah, we will be starting the Q&A session now. And if you guys have any questions, you all can drop them on the chat or even unmute and ask. Yeah, seems like no one have questions. Okay, so yeah, I'm sure most of y'all must have learned something new today and got a very good understanding about AWS Application Integration Services and also the SQS. And now I would like to take the time to thank Manoj for accepting our invitation and taking time from his busy schedule and sharing his knowledge with all of us. So thanks a lot to everyone for being supportive throughout this session. And also don't forget to keep in touch with our social media platforms regarding the upcoming webinars. So thank you all for joining and have a nice day.
Thanks, Shoaib. Thanks for inviting me.
Yeah.
See you guys. Bye.